Here's something that'll blow your mind. The average new car in 2025 weighs about 600 pounds more than it did in 1985. That's like carrying 3 extra passengers everywhere you go. And every car manufacturer, engineer, and environmental group has been screaming about making cars lighter for decades. The answer is hiding in plain sight. Actually, it's touching the ground right now. Your tires. Those 4 black donuts have completely rewritten the rules of automotive engineering, and almost nobody's talking about it. For most of automotive history, lighter meant better. Period. Colin Chapman, the legendary founder of Lotus, had a philosophy: simplify, then add lightness. It worked. His featherweight race cars destroyed the competition. This wasn't just racing ideology. In the 1990s, Honda made the Civic lighter with each generation. The 1996 Civic weighed around 2,400 pounds. Engineers stripped weight everywhere: thinner sheet metal, hollow sway bars, lighter glass. The result? Better fuel economy, sharper handling, more fun to drive. Every automotive engineering textbook will tell you the same thing. Reducing weight is the holy grail. 1 pound of weight reduction can save 0.02 pounds of fuel over a vehicle's lifetime. That adds up fast when you're talking hundreds of pounds. Let's rewind to 1975. If you bought a sports car, you might get 205 millimeters wide tires. That's about 8 inches. And those were considered wide. Most family sedans rolled on 175 millimeters tires or narrower. Fast forward to today. A base model Toyota Camry sits on 235 millimeters tires. That's over 9 inches wide. A standard Camry, not a sports car, not a performance variant. The basic family sedan. But here's where it gets wild. A 2024 Porsche 911 GT3, one of the most hardcore track-focused cars you can buy, wears 275 millimeters fronts and 335 millimeters rears. That rear tire is over 13 inches wide. For comparison, that's wider than the entire wheel of most cars from the 1960s. Why does this matter? Because tire technology advanced so dramatically that the entire equation of vehicle dynamics changed. Modern ultra-high-performance tires can generate over 1.4 g of lateral acceleration. That's 40% more grip than performance tires from the 1990s. Summer tires today outperform racing slicks from 30 years ago. This isn't incremental improvement. This is a revolution. Here's where lightweight engineering started falling apart. Imagine you're an automotive engineer in 2005. Your job is to make a sports car that can lap the Nürburgring faster. The old playbook says, strip weight, add a bit more power, done. But you've got these incredible new tires. Michelin Pilot Sport Cup 2s. They can handle massive cornering forces. There's just one problem. To use all that grip, you need weight. This sounds counterintuitive, but it's physics. Tires need vertical load to generate grip. The more weight pushing down on a tire within its operating window, the more traction it can generate. This is why Formula One cars have massive downforce wings. They're artificially adding weight to the tires without adding mass. So you've got this incredible tire that can theoretically pull 1.5 GS. But your lightweight 2,500-pound car? It can't put enough load on the tires to use that potential. The tires are overqualified for the job. Meanwhile, your competitor builds a 3,400-pound car with the same tires. In slower corners, your lightweight car still wins. But in high-speed sweepers where grip matters most, the heavier car loads those tires perfectly and pulls away. Let's look at Nürburgring lap times, because that's where the rubber meets the road, literally. The 2004 Porsche Carrera GT, 3,042 pounds, 612 horsepower, advanced tires for its era. Nürburgring lap time, 7:28. The 2023 Porsche 911 GT3 RS, 3,268 pounds, 518 horsepower, modern Michelin Cup 2 R tires. Nürburgring lap time, 6:49. Wait, the heavier car with less power is 39 seconds faster? Around a 13-mile track? You can't explain that without tires. The GT3 RS uses every ounce of those modern tires' capability. The contact patches are larger, the compounds stick better, and the tire construction handles heat cycles that would have destroyed older tires. Or look at the Dodge Viper ACR. The final generation in 2017 weighed 3,374 pounds. That's heavy for a sports car. But it set production car lap records at multiple tracks. beating cars that were 500 pounds lighter. How? Massive aero, massive tires, and enough weight to make those tires work. Once you accept that you need weight to maximize tire performance, everything cascades. Bigger tires mean bigger wheels. Bigger wheels are heavier. You need beefier suspension to handle the forces from grippier tires. Stronger brakes, because you're carrying more speed into corners. A stiffer chassis because the tires are transferring more force through the suspension. A bigger engine to move all that weight. Each change adds weight, which actually helps the tires work better, which justifies the weight, which encourages more performance-adding features. The 1991 Acura NSX weighed 3,010 pounds and was considered a heavyweight compared to Lotus and Ferrari. It was also considered slow by supercar standards despite being brilliantly engineered. The 2024 Acura NSX Type S weighs 3,878 pounds. That's 868 pounds heavier. And it's faster everywhere. Not just in a straight line, around tracks, through canyons, everywhere. Engineers didn't lose their minds. The rulebook changed. Now throw electric vehicles into the mix, and things get really interesting. The Porsche Taycan Turbo S weighs 5,132 pounds. That's absurdly heavy. It's also absurdly fast. It lapped the Nürburgring in 7:33, faster than the legendary Carrera GT we mentioned earlier. How? Tires and weight distribution. The Taycan's battery weight is low and centered. It pushes down on all four tires evenly. Modern performance tires can handle that weight and convert it to grip. Tesla's Model S Plaid weighs over 4,800 pounds. On a racetrack with proper tires, it's faster than sports cars from just 10 years ago that weigh 2,000 pounds less. The traditional lightweight wisdom says these EVs should handle like boats. But they don't. The tires are so good that they can manage the weight and still generate massive cornering forces. Now, here's the thing nobody wants to admit. This isn't all positive. Heavier cars wear through tires faster. They use more energy, whether that's gas or electricity. They require more raw materials to build. They put more wear on roads. They're more dangerous to pedestrians. And from a pure driving feel perspective, many enthusiasts will tell you the lightweight cars feel better. A Mazda MX-5 Miata at 2,300 pounds feels more alive, more connected, more playful than a 3,500-pound sports car, even if the heavier car is objectively faster. The problem is that objectively faster wins races. It wins magazine comparisons. It wins customer perception. So manufacturers chase lap times, and lap times favor the tire-optimized weight approach. So where does this go? Are cars just going to keep getting heavier forever? Probably not. We're starting to see diminishing returns. There's a weight threshold where even the best tires can't compensate anymore. Most sports cars seem to be settling around 3,200 to 3,600 pounds as a sweet spot. The next frontier isn't lighter cars. It's smarter weight management, active aerodynamics that add downforce without mass, adaptive suspension that optimizes tire contact patches in real time, maybe even variable compound tires that can adjust their grip characteristics. But the era of the 2,000-pound sports car? It's probably over for mainstream manufacturers. The tires are too good, the performance expectations are too high, and the physics just works better with modern tire technology at higher weights. Colin Chapman's "add lightness" philosophy made sense when tires were the limiting factor. Now that tires are the enabling factor, the equation flipped. Your car is heavier than ever. And weirdly enough, that might be exactly why it's faster than ever. Thanks for watching. If this changed how you think about car weight, hit that subscribe button and drop a comment. Would you rather have a 2,500-pound car that feels amazing or a 3,500-pound car that's faster on paper? Let's argue about it.